When we think about power in the solar system, we think about the Sun. But in terms of gravitational dominance, besides the Sun, nothing comes close to Jupiter. In this episode of Infinity Beyond, we explore the immense gravitational reach of the gas giant and how it sculpts the orbits of asteroids, shepherds comets, and protects, or endangers, life on Earth. Jupiter contains over 70% of the non-solar mass in our solar system. That's more than twice the combined mass of all the other planets, moons, and asteroids put together. This mass gives Jupiter incredible gravitational influence, and this influence stretches well beyond its orbit. Let's break down how. Asteroids and the asteroid belt. Jupiter's gravitational pull is responsible for shaping the asteroid belt between Mars and Jupiter. In this region, objects orbit the Sun, but certain orbits are unstable due to orbital resonances with Jupiter. These resonances create Kirkwood gaps, empty zones in the asteroid belt where Jupiter's gravity clears out material by nudging objects into new orbits, often sending them flying into the inner solar system. That might sound dangerous, but it also helped prevent the belt from forming a planet. Without Jupiter, we might have had a Mars-sized world between Earth and Jupiter, with unpredictable consequences for Earth's orbit. Trojan asteroids, Jupiter's bodyguards. Jupiter also hosts Trojan asteroids, two massive swarms of objects locked into stable Lagrange points, 60 degrees ahead and behind the planet in its orbit. These space rocks are gravitationally balanced between Jupiter and the Sun. Some are over 200 kilometers wide, and many are likely remnants from the early solar system. NASA's Lucy mission is currently on its way to explore these Trojans, offering insight into the formation of gas giants and the building blocks of planets. Planetary migration and orbital shaping. In its early days, Jupiter may have migrated inward and then outward, a theory known as the Grand Tack hypothesis. This tack, like a sailboat changing course, would have disturbed the protoplanetary disk, influencing how and where the other planets formed. Some simulations suggest that without this migration, Earth might never have formed, or could have been a much larger, ocean-covered planet, more like a super-Earth. Comets and the Oort cloud. Jupiter also has a profound effect on long-period comets that enter the inner solar system from the Oort cloud. Its gravity can do three things: capture them as temporary moons, eject them entirely from the solar system, redirect them into orbits that cross Earth's path. In this way, Jupiter acts as both a cosmic shield and slingshot. It protects Earth by absorbing or deflecting dangerous objects, but can also send them our way. A famous example is comet Shoemaker-Levy 9, which broke apart and slammed into Jupiter in 1990. The impact created fireballs, larger than Earth's diameter, a reminder of what Jupiter can intercept. Earth's orbital stability. Jupiter's mass also contributes to the long-term stability of Earth's orbit. It acts as a kind of gravitational anchor, balancing the solar system. Without Jupiter, the orbits of Mars, Earth, and even Venus could become more erratic over millions of years, potentially causing orbital instabilities or increased collisions. In fact, studies have shown that Jupiter's position helps dampen chaotic motion from the outer solar system, allowing Earth to remain in the habitable zone with relatively stable seasons and climate. Influence beyond the solar system. The study of Jupiter-like exoplanets has exploded in recent years. Many large gas giants have been found orbiting other stars, often much closer to their host stars than Jupiter is to the Sun. These so-called hot Jupiters are believed to have migrated inward over time, sometimes destroying or ejecting smaller terrestrial planets. Jupiter's position in our solar system may be unusually favorable for life, far enough out to protect the inner worlds, but close enough to maintain order in the planetary orbits. Jupiter, then, is not just a planet. It's a gravitational architect, a cosmic gatekeeper, and a planetary protector, and sometimes a potential threat. In our next episode of Infinity Beyond, we'll step even farther out into the region of the Trojan swarms and explore what NASA's Lucy spacecraft hopes to find in this ancient debris field.